When solving equations in algebra, I need to do so using inverse, meaning opposite operations. And I always need to perform my inverse operations according to the reverse of PEMDAS. That means usually my first inverse operation will be to add or subtract, and my second inverse operation will be to multiply or divide. That will be the case for this first example, 2x minus 4 equals 6. The first operation that I would like to undo is minus 4. And so my first inverse operation will involve addition. To undo subtracting 4, I would like to add 4 to the left-hand side. 2x minus 4 plus 4 undoes that minus 4 and just leaves me with 2x. Since I've added 4 to the left-hand side, I have to also add it to the right in order to maintain my equality. So 6 plus 4 is 10 is the right-hand side of my equation. Again, I chose to add 4 to undo minus 4 so that I'm left with just 2x on the left-hand side. Now I only have one operation to undo. X times 2 has an inverse operation of dividing by 2. So I undo times 2 by dividing by 2. My second inverse operation involves division. 2x divided by 2 is just x, and 10 divided by 2 is 5. X equals 5 is my solution to this first equation. Before I move on, I want to point out a trick that is not acceptable in algebra. Some of you may have been taught, instead of adding 4 to both sides of the equation, to just move that 4 to the other side of the equal sign, making it positive. This is considered a trick and is not acceptable work in algebra. The effect of adding 4 to both sides is the same. I end up with just 2x, and then I get 6 plus 4 on the right-hand side. However, this trick did not justify why that happened. How did the 4 become positive? Why did it disappear from the left-hand side? So if this is your habit, if this is what you've been taught, I need you to erase it from your memory banks and to instead use inverse operations to justify each of your steps. Also, before moving on, I'm going to introduce this perhaps helpful strategy of using a flowchart to help you figure out in which order you should perform your inverse operations. So when we're using this flowchart, we think about what's happening to x in my original equation. Using my normal order of operations, what is happening to x is first I'm multiplying x by 2, and then I'm subtracting 4. Normal PEMDAS, times 2 minus 4. What happens is I end up with 6 after I've multiplied x by 2 and subtracted 4. Now when I'm trying to solve, I have to do that in the reverse of PEMDAS, in the reverse of what I originally did in my equation. That means first, I'm going to undo subtracting 4 by adding 4, and then I'm going to undo multiplying by 2 by dividing by 2. This gives me my right answer. I start with 6, I add 4 to get 10, I divide by 2, and I get 5. This little flowchart may be helpful to you. If it is, great. If it's not, this is not required work. However, some students find it really beneficial to trace through what's happening to x so that they can solve in the opposite order. Let's go ahead and look at another example. X divided by 2 plus 4 equals negative 6. This is another typical two-step equation in which my first inverse operation involves addition or subtraction, and my second involves multiplication or division. The first operation I'd like to undo is adding 4, and I do that by subtracting 4 from both the left-hand and the right-hand side. X divided by 2 plus 4 minus 4 just leaves me with x divided by 2. And then negative 6 minus 4 is negative 10. Second inverse operation involves the opposite of dividing by 2. It involves multiplication. So to undo dividing by 2, I'm going to multiply both sides of my equation by 2. X divided by 2 times 2 is just x, and then negative 10 times 2 is negative 20. Negative 20 is my solution to this equation. Let's go ahead and use a little bit of a simplified flowchart to understand why we first subtracted and then multiplied. So to use my flowchart, I think about what's happening to x in my original equation. What's happening to x according to my normal order of operations is first I'm taking that mystery number and dividing it by 2, and then I'm adding 4. Knowing that I need to solve in the reverse of that order of operations, I know that first I need to subtract 4, and then I need to multiply by 2. First I subtract 4, and then I multiply by 2. Again, the flowchart is not required, but if you're confused as to in which order you perform your inverse operations, trace through what's happening to x in the original equation, and then solve in the reverse order.